Welcome to Strength of Material lectures by Civil Thinking, and this is our first class on torsion in shafts. Before I move on, I suggest you to please watch the video lectures on torsion in shafts one by one as in the playlist so that you understand better. The playlist link of torsion in shafts is in the description, or also you can click on the pop-up on your screen. Now coming to today's class. Now in this class we are going to define basically what is torque, okay, what is torsion basically, what is the relation between force and a torque. Okay, so to begin with, let me show you a transmission shaft of a typical car. Okay, now when you look at inside the car, you can see that it has a shaft. Okay, and there are two tires right on both the sides. Okay, now what happens when you apply a force F? Okay, let us say we have applied a force F, okay, which is tangential to this tire or whatever you call it. Okay, now what is going to happen if this tire is going to rotate? Okay, so let me show you like this. So when you apply a force, you are going to see it is going to rotate like this. Okay, of course it is not perfect circle, it's a very bad tire, right? But you can see it is rotating. Okay, why, how did this rotation happen? It happens because when we applied the tangential force, it will begin to rotate. Okay, and also you will notice in the cars, you will see that the axis of rotation is along the shaft. Okay, so when you apply the tangential force, what happens? The tire rotates along about the shaft. Okay, so because this tire rotates when we apply a tangential force, it rotates about this shaft. Okay, so we can call this as axis of rotation, right? Now what is the relation between torque and torsion? To illustrate this, let me draw the diagram again. Let us say this is the force, tangential force F. Okay, let me draw it. Okay, I draw it tangential. Okay, now let us say we have a radius R. Okay, R is the radius of this. Okay, now what is torque? Torque is basically the product of this force and R. Why R? Because R is the distance from what? This is the axis of rotation, right? This is the point here. Okay, so R is the normal distance between what? The axis of rotation and the tangential point from which point on which the tangential force is acting. Okay, so from here we can find torque as cross product of force and the distance. Okay, we also call this as lever arm. Okay, now this is the torque. Okay, and if we want to find the relation between force and torque, so it is this. Okay, you can see torque is directly proportional to the force. Okay, so the more force you apply, the more torque is generated. Okay, so if I write about this here, tangential force F tries to rotate the object about the axis of rotation. Okay, and by the way, we as a shortcut we write it as AOR, which means axis of rotation. Okay, now torque, what is torque? Torque is the product of tangential force and the normal distance between the axis of rotation, right? Because as you can see here, R is the what? It is the normal distance. Okay, it is the normal distance between the point, this is the point at which the force is applied, and the point of the axis of rotation. Okay, so I can write it is, torque is the product of tangential force and the normal distance between the axis of rotation and the point where the tangential force is applied. Okay, so if F is the tangential force and R is the distance between the axis of rotation and point of force or point of application of tangential force F. Okay, then what's the relation? Torque is cross product of force and this normal distance. Okay, so what is F? F is the tangential force, okay, and R is the distance between axis of rotation and the point of application of torque. Okay, so this provides us the definition of torque itself and the relation between force and the torque. Okay, so what do we have to note? If the force is more, the torque is going to be more. Okay, and similarly, if the distance between the axis of rotation and the point of application of force is more, okay, then also the torque is going to be more. Okay, so I think that is it for this lecture. If you have any doubts, okay, you can comment, and see you in the next class. Thank you.